That's
Oh, the abrupt start. I started the soundtrack a little later than normal, so we didn't get the full 5 minutes of awesome retro 80s soundtrack in. But I am excited to be here with Charly. Charly, what's up, my friend?
Hey Matt, how you doing?
I'm doing great. So, thank you everyone for joining today. We've got the Postgres meetup. This is one of our weekly meetups that we do on different database technologies, different open source technologies. We are glad you came, and for those watching live, welcome. For those watching recorded, welcome. A lot of people at KubeCon this week, so always exciting. We just actually released our operators for Postgres, so we've got a few people out there walking around, talking with folks, shaking hands. I wish I was there, but I'm not. But I'm glad I'm here with Charly, right? So, so Charly, thanks for joining. I know we've got some topics that we wanted to cover. For those who are online, feel free to come on over to chat. I'm going to pop the chat up to our right here, and you can ask questions. They'll show up live here. Appreciate any of the questions, and we'll dive into questions as time goes on. But I wanted to start with personal stuff, because why not? And so Charly, I don't know about you, but being on call is hard, right? I mean, it's a hard thing, and I used to be a DBA who carried the pager around and got called all the time. And we all have shifts now, and so whether you work in support or you work in managed services with Percona or anywhere else, we're fortunate where we really don't have to have that pager kind of philosophy. And heck, I haven't had to carry a pager in 10 years, I think, or 20, 15 years.
I think it's more, at least 15 years,
Yeah, it's
ancient technology.
Yeah, well, I mean, phone, pager, yes. Okay, I just dated myself for everyone on the thing that I said a pager. Yes, I actually did carry a beeper. Yes, but then it later morphed into phones that went off constantly. And so I'm really tired today. You probably can't tell because I had a ton of coffee and soda this morning to pep up my caffeine. Because you are always on call when you have kids and dogs. Now, my daughter's 20, right? So she's no longer considered a kid, but she still lives at home. And she loves her dogs. And unfortunately, she buys these boxes that get sent to her that have like all these dog treats and dog toys. And she did that over the weekend. She got a new one, and she's here, let me go throw the toys. And she's got these treats. And our biggest dog, he's an old English sheepdog. He has a very sensitive stomach. So she's been giving him these treats like all day long. And 2 o'clock in the morning, dog starts whining and crying because it's got an upset stomach. And and my daughter, she's 20. She knows that like the dog is going to have issues. But so I was up at 2 a.m. With the dog. But I did get a chance to dig into some PMM code at 2 a.m. So I didn't make the most of my experience. But thank God we don't have to have that kind of pager mentality anymore. That's always a rough thing.
Yeah, it is. I mean, when I started working in IT industry, it's like 20 some years ago. I remember our department was one of the first in the company that we got a mobile phone back at the time. It was a huge Motorola, it was really big one. And well, we had to carry the mobile phone, right? And it was so awkward when we got the call, you are in the middle of the street, and then you got the call with that giant thing, and everybody looking at you, and you're like, "Oh my goodness,"
Yeah. Well, And when you got those calls, how often was it something that was actually broken versus slow?
Yeah, mostly back that time it was mostly broken.
Was it?
Yes, and well, and some things. This is the thing when you work on the database. Like you never want to get the call, right? Especially when someone called to you and for look, well, the production is gone. Like, and the company that was working, it was retail company, so they used to like to have a branch. They were selling things there, and the database was down, so that the shop was just stopped,
Oh,
and it was really on fire. So and then yeah, you just got attacks and just ran out, and we didn't have the what we have today. Now it's just log in SSH and then whatever, just fix things, right? But back that time, that didn't happen. We had. I remember that we had those dial connection. I used to have the US Robotics modem. It was also a gigantic one that I had. It was 56 kilobits per second connections.
I had a 14.4 when I first started. So again,
Yeah.
I shouldn't say that because now everyone's going to go look up when that was a standard. All that said, it's funny you mentioned like, there was no SSH. I remember having to go in every Saturday night to the data center and go hit restart like buttons on all of the systems, right? And that was horrible, right? Yeah, so I think that's something that we have now today. In modern times, people still unfortunately have to get called in the middle of the night. A lot of SREs are always busy. And, a lot of times those are not necessarily those outage type things because, there's a lot of automation for failover, high availability. Mm-hmm. There's a lot of, different things out there for, making sure databases stay up. But we get a lot of those kind of slowdowns, as Diego said, he'd rather have a dog call at 2 a.m. than a customer call in at 2 a.m. Yes, I think that, we do see that all of a sudden you'll get the call, oh my gosh, the system is slow. And of course, if you're in the position of being an SRE, a DBA, it's always the database's fault first. Let's be honest. It's never the application, right? And I'm pretty sure that's a universal truth. And those watching can probably justify or commiserate with me. We wanted to talk a little bit about, from a Postgres perspective, what are some of those things that we can do to prevent that 2 a.m. phone call when the system's slow because we've got some high, traffic, maybe, a performance slowdown, some other things. So, Charly, you've been doing this for as long as I have. So why don't you start telling us a little bit about, some of the performance gotchas and things to do and not do?
Yeah, well, when it comes to performance and database, it's tricky. I would say we need to start from the very, very beginning, right? And one thing that I've seen all over those years that, like, when I was working with database, is usually the people they spend a lot of time trying to turn in the database, the hardware. Like they go for the configuration, and it's not only in Postgres. Like I've seen on MySQL, I've seen in a lot of other databases. They say, okay, yeah, we're planning for the new system, so we need a beefy machine for the database. Let's buy a beefy machine. Now we can talk about 1.5 terabytes RAM. So 300 cores, and yeah, you can have a really beefy machine for the database. And then they go, okay, what do we do with this box, right? So you have this insane box, and we need to do a lot of optimization. And people, they usually spend a lot of time trying to optimize memory, trying to optimize CPU and all those kind of things. And that's all great, that's all great. And especially because most of the database, their configuration, when they come from the full configuration, they are old setup, old settings. Those settings from when we used those US robotics 56 kilobytes, right? So the full configuration, they do not follow what we have today. So it's possible that you can have, let's say, 5-10 times performance improvement when we do a really good configuration for your box. And then you get fine for some time. And the system is working and everything is working fine. And when you reach the point that even with that amazing diffie machine, your system or your database start performing really bad. And then people, they go, and a lot of companies that have a lot of money is what they do. Okay, let's improve the machine, let's improve the box, and so on. Eventually, things start slowing down. And one thing that I don't see most of the companies doing is trying to understand why the performance is dropping. And this.
So is it more that they're trying to fix the symptom than it is
Yes.
to actually oh, it's slow, let's just do whatever to make it fast and never fix why it ended up.
Let's add more memory, right? Like, it's slow, let's add more memory or more CPU, so let's make things faster. But thing is, it's not scalable. It's totally not scalable. At some point, you're going to have 100 terabytes memory and your database is still slow.
Well, is this a myth or not? So in the Postgres space, Postgres works really well on, general hardware. It's great out of the box for general workloads. But, when you start to get, these massively sized boxes, sometimes, it's just not optimized for it. I've stunned Charlie into freezing right now. Isn't that always like the case? Oh, Mr. Charlie. Oh,
I'm back.
Oh, you're back. Wonderful. Wonderful. So
what happened? Okay.
I don't know, but I was filling dead air. I was going to start singing, so you've saved everyone from that. So everyone can thank Charlie for that. So Charlie, my question to you was, you mentioned about getting these bigger and bigger boxes.
Mm-hmm.
And, one of the things that I have heard, and you can confirm or deny, that at the larger sizes, the scalability for Postgres doesn't, it's not like you go 2 times the size and all of a sudden you get 2 times the performance, because Postgres works really well on the smaller, systems and the moderate range systems. But as you get bigger, there are some limitations.
Well, yeah, it's true. And not only for Postgres, scalability is not linear, right? It's not linear. You're going to reach at some point that your performance doesn't scale linearly. So it starts to drop. The curve starts going down. Especially on Postgres, a huge limitation on Postgres is how Postgres use the resource. For example, Postgres relies a lot on the operational system, right?
Yeah.
So when I say Postgres relies a lot on the operational system, is that even though Postgres has its internal memory buffer, so its I/O subsystem is delegated to the OS. And most of the caching for the buffer itself is delegated to the OS. And if you're not careful enough, you can have a lot of data inside of Postgres buffer and on the OS cache. So you can have performance drops. And on that say is usually you get a huge improvement on performance when we really understand your data model, right? So you understand your data model, you will start to sanitize your data model, to add the index where the index are needed, remove the index where the index are not needed, because sometimes the people just say, okay, it's slow, add another index. And then you realize that Postgres doesn't use that index, you know? And just to make a comparison, it happens because of the implementation that Postgres team decided to do for the storage subsystem. So MySQL, for example, they use a primary key to order the table, right? So on Postgres, they use heap tables, heap files. So it's just a collection of blocks, one after another. The file on Postgres is really simple how it stores on file. So, and then it's much cheaper if you just need to do a full table scan, because you can just open the file, go from the beginning to the end of the file. So linearly, you do a full table scan. It's much cheaper if you need to go to the index. So your index needs to really be a good index for the optimizer to decide to use the index on Postgres. Because when you go to the index, you need to read on the key order. If it's like, for example, a B3, so you're going to have a lot of random IOs on your disk. And those random IO from the disk then needs to be translated to find the page inside of the table itself. So when you're doing an index scan on Postgres, you're just changing the pattern of the access from a sequential scan, that is the full table scan on Postgres, to a random IO on when you are using index. What happens on MySQL, for example? MySQL always does a lot of random scans, because the file itself, the IB data, I'm talking about NOTP, the IB data file, is saved on index order. So it always does. That's why on MySQL, a full table scan is so much expensive than it happens on Postgres, right? So, and then, for example, when we had for a customer, they were having a lot of performance issues, and we reviewed all the configurations and the setup, and they were getting the best for the box. You know, the setup that they're having the best for the box, but it was still slow. So then we just did a couple of changes on the data model on some tables. We just went there, changed a couple of things, and we got around 20% improvement of the queries.
That's a big improvement,
yeah.
Right? And I actually have a test, and if we have time, maybe at the end I can do it to show everybody. But I've set up something where, I've got a benchmark thing that we've been running at demos and things where we use this thing to control like Postgres, and this right here actually changes the primary key to a varchar, and this one changes it back to an int. And so we can watch on PMM, like when we do that, we can run workload and we can say, like, what does this look like when you're running here with the integer, you flip that to a varchar, what happens?
Mm-hmm.
And so any guesses on what the performance hit was on my benchmark? Just out of curiosity.
Well, it's easy to understand. Like, of course, it's gonna drop, especially if you need a range scan, right?
Yeah. So, any guesses? Like, just
how much?
10x, 5x, 30x, 20x, 100x.
Well, no guess.
No guess. Oh, come on! You're not even playing the game. All right. So I'll tell you what. In the tests, as we were doing this, we were seeing anywhere from like a 20 to 30% or 20 to 30x difference. X, not percent. X.
Yeah.
And so I think that's one of those things that you need to think through. So we do have some questions popping up here. If we wanted to take a couple.
Sure.
So first one from Gittes, does anyone have a good way to limit the memory a single database user is allowed to consume in the single query? And I mean, and Charlie, you can jump in here, but I think that question is interesting because the answer is not really, right?
Not really.
Because even if you limit like the user, what's available to a user, the file system cache can still consume quite a bit of memory, and the system itself is not going to discriminate where it's pulling, data from. So if you've got a terabyte sized table that one user happens to be reading from, you could potentially limit, some of the sizes of some of the caches that the user itself is, but all of that terabyte of data that's potentially being queried is going to end up in the main memory pools, right?
Exactly. And this is the thing that we need to understand when we are working with database. There are so many things that goes beyond the database itself. Like, even though you can limit resource consumption inside of the database, sometimes your database going to just ask more for the OS because it needs to use. And if the OS has more to give, it will be given to the database. And those are the things. So we need to separate the layers. Okay, what is the database layer? This is the layer that the user gonna interface, is the database. But there's a lot of more things behind that database layer on the OS, for example. And I have a question for you. Do you know why, when you change for the integer to a varchar, the performance drops so significantly?
Well, there's actually a couple reasons. I mean, and I'll theorize, and you can tell me if I'm right or wrong. Right. Number one, you're going to be consuming more memory, potentially quite a bit more memory, especially when you look at like a UUID or something that is a 32 character field, as opposed to a byte field, which is going to be 4, right? So, or an integer field, which is going to be 4. So, that is a substantial difference in just the memory consumption, as well as a substantial difference in the disk space. So I think that those two are definitely something that impacts it. But there's also a CPU overhead of comparing and checking the two character fields. That's more than the yeah. And I mean, so you do see that as both a limiting factor. Now, when I used to do the same testing in MySQL, and actually I can flip that same test to MySQL, and we get a similar performance impact, probably a little worse in MySQL, because MySQL is using in MySQL, each index has the primary key in it.
Yes.
Which means that you take up even more space.
Yeah. Well, those things definitely play along. And also there is a third one that has a huge impact, is the organization of the B-tree itself. So when you choose an UUID, for example, your index is not sequential. It's not sequential, your index. So it may looks okay. It looks okay because in the end you're organizing the index, right? But when you have a comparison, a range comparison, and you do not have sequential keys that you're searching on the database, so it needs to do a lot of random I/O. And remember, like, even though the space in memory is much larger, we have a lot of more CPU comparison, but like CPU and memory, they're still way faster when we talk about I/O. Right? So because if you do a lot of random IOs, and even on SSDs, random IOs are at least 2 or 3 times slower than sequential IO.
Yeah.
And all because like one of the big thing that plays on SSD that's probably random IO will never be as fast as sequential IO is because of prefetch. So when you have sequential data, you can prefetch blocks in sequence. Right? So if you prefetch that and put in memory, that is much faster than just waiting for the CPU to request the next block and you're going for like random blocks. And this is one thing that plays a lot, and also on SSDs. And like people think, I moved from spinning disk to SSD. Everything going to be much faster now. I don't have any random IO issues anymore, but well, not true, right? And as you said, on database like MySQL that has cluster index, they are even worse because of you need to carry the primary key for all of those indexes.
Yeah.
And another thing that usually we don't pay attention when we are designing database on Postgres is what we call padding. And when we're saving the data What Postgres does, it has a word size of 8 bytes that it's trying to save all the fields to align with the CPU word size. So if you have, for example, a column that's ID is integer or big integer that it has 8 bytes, so it's gonna occupy one word size, right? So if the next one is a varchar, so the CPU doesn't know how much bytes that can occupy. So then it can, because it's a varchar, you can change the size. It can occupy a lot of space. If it's in the end of the table, there's no problem because it uses as many words as it's needed. But if it's between two, everything that is not in the length of 8 bytes, you'll be padded to be of 8 bytes. So I did a very small experience already with one table. Well, it was out of 7 columns, and all columns were of different types of integers. So they were small columns, right? And I sorted a million rows and like just put the data randomly, like just like we do modeling, like ID, date of updates, Boolean values. So just like you're modeling your database, you just distribute the data as it looks okay. And I got the final size of the table was 75 megabytes. And then I just reorganized the very same table, putting the pad on optimal disposition of the columns. And I inserted the same data. I did a insert select to get the same data from the previous table. And it was of 55 megabytes. So it was 32% difference in size of the data just because I reorganized the data.
But space is cheap.
It is, but remember, it goes to memory and the CPUs need to work on this.
Yeah. Well, right? and so Hamid had an interesting comment about like asking if it's a clustered index, because a lot of people don't use clustered indexes because they don't even know that they necessarily exist, right? So a lot of people make that mistake where they're just going to go create index and they're going to be done with it. So that is an option that you can look at, clustered indexing, to improve performance. We did have another question from Dilip, and I wanted to be mindful of some of these questions because some of them are good. So there is a question from Dilip, which now actually just disappeared. So I'm going to go ahead and throw this on the screen. They're trying to insert a 10 million record into a foreign table by using Postgres FDW, and it's taking a time of 3 to 4 hours. Is there any way, fast way to test it? Now, I mean, I wish Ibar was here because he knows everything there is to know about foreign data wrappers, right? So he tends to be one of the go-to guys for that. And I think that Naeem said, he was asking what kind of tools you're using. But I think a lot of this is for testing. It depends on the outcome of the test that you're looking for. Are you looking for a realistic test, like one that's going to be in production, or are you just looking to generate test data to get something that you can play with? Because I think that, when you start to look at trying to speed up load processes, there's definitely things you can do, things you can disable. You can look at what, extensions you might be running and seeing which ones might be impacting performance, seeing about disabling some of those. I think that, you can also look at, if you just want the data, it's probably going to be faster to, take the data and then load it and not go through the foreign data wrapper, if that's possible as well. Charlie, any suggestions?
Well, for the tools that we can use, I like to use Sysbench, right? So to generate some TPCC tests, it's a good tool. There is one tool that I also like a lot, that is HammerDB. So it's a very interesting tool when you need to generate a massive amount of tests for the database. You want to test performance improvements, and they have a really nice driver for Postgres. It's a pretty good one. And there's the PG bench, the full one for the community. People are, well, they are like, depends, as you said, depends on what is your goal, what you want to achieve from the test, right?
Yeah, and I think from I think Dilip's point was that they're specifically trying to test. I don't know if they're trying to test the 10 million insert load, or if they're just trying to get 10 million rows over and then test against 10 million rows. I think that might need a clarification.
It's because I saw another question, the guy asking about the testing tool. I thought you were talking about this.
Yeah.
Oh, no, the Postgres FDW. Well, there are many things that can be impacting. First one that I will take a look is network. Are those two databases on the same box, or are they in different boxes? So how is the networking playing along, right? So because when we are looking for optimization, we are trying to follow the 80-20 rules, right? You want to try to get the 20% optimization that gives you 80% improvement, right? Then usually you go for the first things that you go to do are the things that are the lowest one. And usually network, IO, and network in this sense is the slowest one. Right. So first thing I would take a look is the network.
That's a good point, especially with foreign data wrappers. If you're pulling data, let's say out of Oracle or some other database somewhere else, you might have that in a completely different data center.
Exactly. So yeah, that's the first thing. But let's say, okay, no, they are in the same box. Okay, they are in the same box. And if you do a select, how long that's gonna take? Because pull the data from one of the databases is slow. On the other database, do you have the indexes? Are the indexes enabled? Maybe you can just disable the indexes, all the checks right now, if the table has a lot of checks. So sometimes it plays a lot of impact, right? Disable the checks, do the load, and then just enable the checks again. They recreate the index and all this kind of stuff, right? Those are usually the ones that cause more problems when we are moving data from one place to another one.
Okay, so let's see what else we got going on here. So I did see a couple other questions come in, so I'm working my way through them. Diego actually said, this pad thing is interesting, but why can't Postgres just rearrange the columns under the hood by default? It would be nice. Let's be honest, it would be nice.
Yeah, that would be, but the thing is, it is complex. Especially because you might have a logical reason to have the table on using that sequence, right? That sequence of columns. So the thing is, when you put too much intelligence and logic inside of the tool, the chance that something bad happens is too high, right? Mm. So, and then, okay, you need to spend a lot of time to develop that feature. That's something that's pretty much easy for the user to do by itself, right? How much does it worth to try to add bugs and complications inside of the database itself? If you can, it's just like the user can be careful and create it by itself.
And I think that, as Hamid points out, that there already has been some optimizations. As new versions of Postgres get released, a lot of these things start to get better and better over time. And this is where a lot of times the difference between one or two versions in Postgres can make a massive amount of difference in performance for certain workloads, right? Or
that's
space
true.
savings.
That's true. And for this case specifically, I haven't tried on Postgres 14, but it still plays a lot on 13.
Okay. And so, Hamid, do you know if that's a 14 improvement? I'm not 100% sure. I remember seeing that in the list, but it was a pretty big list of features in 14. Let's be honest. So, I mean, I think it's easy to miss some of those.
And it just came out, right?
It just came out, yes. But I had two blogs. I had two blogs on it already. So
it's fresh from the oven.
Rocking it. All right. So Hamid also has said that Sysbench, PGBench, HammerDB, good tools. Orlando wants to know, and so let's just jump right into Orlando's question here. How and when do you tune the hash mem multiplier?
Oh, that's a very specific one. Hashman multiplier. I don't remember top of my mind. I
As
really
we
need
all
to
go
yeah.
Google Hashman multiplier to see what it is. See, like, I am not 100% sure, Orlando, personally. Hamid, is that something that you are know the specifics on when to tune that?
Oh,
Yeah.
okay.
And what did you? So as Charlie, catches up here.
Okay, I see. It's used to compute the maximum amount of memory that hash-based operations can use. Uh, well, thing is, there are many situations that you can use some Postgres can use hash operations like right. So, for example, when you do a full table scan and you need to compare two different values, Postgres can create two hash tables, can create the hash tables and compare those two different tables. For a join, for example, it's cheaper when you have hash tables and compare. So if you have good indexes, most of the time you won't need to care about the parameters, so the full value. So I would go to check why the database is creating too many hash tables. So probably because there's no good indexes, and most of the operations probably going to be because, as I said, it's doing some joins or some comparisons and just create the hash table to compare to make it easier. And this is also happens on another one when we have a lot of bitmap operations on Postgres. So there are many ways that the database can compare the data when we are join tables or when we are going for a full table scan, right? So one is to create the hash tables, and MySQL also does that a lot when comparing two tables on a join. Another one is on the bitmap operations. So the database, it can get the data from one table and create a map of bits from that data to make the comparison faster and easier on the database. So if you go to your logs and you see too many hash tables that being created or too many bitmaps operation that being created, it may be possible that your database design is not optimal. May be possible that you need to reorganize the indexes that you have so to make the performance a bit better. So before, as I said, before going tuning all those many parameters, it's better to understand why your database is performing badly, right? Because the gain is much higher. And again, when you turn one parameter for the database, you turn the parameter for all the loads that you have on that database.
Yeah, so it's not just one query.
No, it's for all the loads that you
I
have in
think
your
this
database.
gets back to the theme that I mentioned earlier, which is database design is so overlooked, and everybody that I talk to ultimately ends up coming back to that same conclusion, that the number one problem that most people run into is they didn't necessarily think through all of the different implications of how they design something or a table, right? And how they design their structures. And because of that, they end up spending more. They end up, running into problems. And, it's very easy to overlook some of those things. Charlie, I know you've been doing some work with JSON. I did some work with JSON recently in the JSON B data types and JSON data types. And I've seen users who just implement those raw and, expect good performance. And they add maybe the wrong indexes. Maybe they don't use some of the generated indexes or functional indexes that you can add. So there's this missing component and then they just kind of throw everything in, and it's just a dumping space for their systems, which is never going to perform optimally.
Yeah, I have an example. When I did a consulting for a big corporation in China a few years ago, and they were moving their data from a proprietary database to Postgres. And on the way, they were also changing the application to use JSON inside of the database. So they had two complications, right? The first complication was move the data from a proprietary database to Postgres. And another complication is you start using JSON, the JSON type inside of Postgres. They were having horrible performance on Postgres side. And when we start looking at the problems, we saw that they had one gigantic table with 5 columns. And that table with 5 columns, they had 160 indexes on that table.
Wow, 160 indexes on 5 columns.
Yeah, and the thing is, one of the columns, obviously, was a JSON.
This is my ugly face.
Yeah. One of the columns was a JSON column. So, and they were using a B3 index to index independent fields inside of the JSON, right? So then you can imagine how especially the writing performance was impacted. Because we need to remember that every time we write to the database, the index needs to be updated. Postgres has this amazing feature that they call hot updates. So when you do an update and this update can be in place on the same page, it doesn't need to update the index. So that's fine. So, but the problem is how much percent of your pages are filled on your database? How much percent of the updates are hot?
Well, does that apply to JSON B columns as well?
It can.
But JSON B so big, will it ever be able to do it?
Can you say that again?
So because as we talk about like JSON, so if you've got a column and you're updating this column, if I recall correctly, JSON the update, it replaces the whole document, so it's always never going to fit on the same page. It's probably going to spill over, right?
Yeah, that's the thing, and that's the thing, and that's what I say. So Postgres has this amazing hot update feature, right? But it only happens when the new data fits on the old page, right? On the same page. So it doesn't fit on the same page, so the index needs to be updated. And if you have on the table 100 indexes, so you need to update all of those 100 indexes, right? Yeah. So then the performance goes really badly. And this is when the thing comes, okay, we're designing, what is the best option that we can use for this design?
Right.
JSON is an amazing thing, right? It can help a lot. It can make the developer lives much easier. Even the database, if used, can make life easier as well, right? So you can go for the gene index, and there are other technologies that we call the whole day talking about that, and to change. So what we did, we removed all those indexes. We just, in that case, we applied a gene index. We did some tricks, and then we got like 40x improvement performance.
Yeah, and I mean, I think that's the thing, right? Is if you properly index and you don't over-index, and a lot of times it is more cost effective when you're looking to store JSON to make sure you've got either generated columns or indexes on this specific things you're going to pull out quite frequently, or even I'm gonna be a heretic here, denormalize some of that, so when your app is writing to the database, it pulls some of those columns out, maybe stores them in different tables, optimizes them slightly different, does some lookups.
Well, that can be done, but we again need to be careful because remember the random and sequential I/O. So what happens is the database cannot read a couple of bytes or a couple of kilobytes from the disk, right? Every time that you ask something from the disk, it needs to be at least one block, right? So if you normalize your data and split the data in between many different tables, you need to ask at least one block for each of those tables. If you have a huge table, like 100 columns on the table, if all of them fit on the same block, so then your IO pattern is much better than having a lot of tables. So it can make things a lot of faster just because you have way less IO.
Yeah. So Hamid followed up on your hot
160.
example. So yeah, so it's an interesting thing because there's these things that you can have work 90% of the time fine, but then the other 10% of the time it hits a limit.
Yeah, exactly.
And I think that's actually a design principle, if you will. And I'm going to go story time for everybody. And so I had recently, so we moved into this house 2 years ago, or 2.5 years ago. And so brand new house, it was built by builders. So we've got a little half bath. So just a bathroom with the toilet and sink downstairs. We had a plumbing issue just recently where we noticed some of the floorboards started to warp, and we noticed some water. So we called the plumber. Mm-hmm. And the plumber says, oh, when they installed this 2 years ago, they didn't install it right. And it actually was missing a part that was very significant. So there's been a slow leak underneath the floor for 2 years. And it reminds me of this type of design principle that we often forget, which is just because something works doesn't mean that shit isn't flowing underneath the floorboards.
Exactly.
And I think that's where, like, we from a development perspective and from a perspective of, designing applications right now, we're so busy. It's so easy to get something to work and then just release it that we often forget that as workload changes, as data size changes, as all kinds of new versions come out, it might not work the same way. And so there isn't this effort to go back and necessarily retest or re-verify the decisions you made originally are still valid. And right now, I think I saw the average tenure for a developer is 1.5 to 2 years at any company. So by the time that something does break or really go bad, they're probably not there to even experience it.
Yeah. And one thing that I've seen over those 20 years I've been working is every time that we face a problem, sometimes it's a very complex problem and go so high level, we need to go deep, then we always end up to the basics. You always end up to the basics, on the basic concepts on how memory works, for example, on how the IO subsystem gonna work, on how the CPU does its job, And I've seen so many misunderstandings that the people have on those things that I would say a lot of problems that have been caused on the database sides, on the application sides, just because a lot of buddies out there, they don't really understand how the implications of how the memory design on modern hardware they work, right? For example, the thing that I just said, the database, it cannot give you a couple of bytes. Even you go to the database, select ID from table user where ID equals 5. Okay, ID is an integer on this example, so 4 bytes, right? So you won't get that one. You're gonna get the whole page. If on Postgres, for example, the page is 8 kilobytes. So you're going to get 8 kilobytes. If you do that very same select many times on just increasing the ID. And for example, your example that the using the not a sequential primary key. So you need to get that page from the index as well, right? If it's not sequential one, if you have split in many pages, so sometimes your select that you suppose you could be fit just one page, you are getting 100 pages from the database. And then you ask, why is so slow?
But I mean, there's so many of those gotchas in the design aspect. I remember back in the day, I worked at a large e-commerce site on their stuff, and they were using an ORM framework, and the ORM framework did select star and everything by default. And so as they were querying things, they only needed one column. And they ended up saturating the bandwidth because they were selecting blobs and text objects that they were never using. And it was all sending it over between the application server and the database server. And they actually flooded, the network.
Mm-hmm.
I mean, and it's not easy to do that, especially when, you're looking at, gig or 10 gig, connections between a lot of these. But their traffic was so heavy and those objects were so large that they actually bottlenecked on it. I mean, and I think that's where understanding and getting back to one of the things you said, fixing the root cause, not fixing the symptom, is super important and critical.
Exactly. And that's another amazing example, because that's another thing that a lot of people they do not realize is whatever that you select from the database needs to go through the network, right? So whatever you select from the database needs to go through the network. And what is your select time? Is the select time just the time that the database takes to get the data and put on the network card, or is the select time the whole time that you do the select, the database get it, and the data is ready for the application to use?
Yeah.
Right? Because sometimes the database takes milliseconds, right, to fetch the data and put on the network card. But the network is slow. Or you are, as you said, you're putting so much data inside of the network that the bandwidth is saturated, right?
Yeah.
And the people, oh no, the database is slow.
Yep. So we're approaching the top of the hour here, and want to be mindful of time for everybody. I don't see any new questions, but wanted to cover a couple things for everybody. So if you're not aware, we are running a survey. Our annual survey is going on right now, which does help not only us, but it helps everybody in the community, because it is a anonymous open survey that anyone can grab the data for. It's all open, but nothing is collected that is PII. So I'm going to go ahead and I'm going to add a link here into this, just so I can make friends with everybody who wants me to make sure we talk about that. So if you do have a second, we'd appreciate it. It'd take you about 5-10 minutes. That really does help us, and it helps anybody who's doing research or trying to look into some of the trends on the open source database side. Also, as you may or may not know, so I have this job in community, and I'm supposed to help connect with you fine folks out there who are on this channel, and I would love feedback on what's working, what type of topics you want to hear. You can say Charlie was awesome and Matt, you were a dud, replace Matt. That's okay. I need feedback on, what you want to hear from us, and what's working well, what isn't. I like to talk, so I can talk all day long, whether you guys want to hear me talk or not. And I'm pretty sure that, you want to hear some awesome technical stuff, and, topics are always good. We also have, I mentioned earlier, our Postgres operator. So if you haven't gotten a chance and you are running on Kubernetes, I would recommend you take a look at it. Join up on our Discord channel if you need some help or you want to ask some questions on it. I'm happy to help out there. I hang out there. Several people from engineering hang out there, from our service team hang out there. Love to hear from you. See what's working, what isn't there. And Hamid mentioned that PG Stat Monitor is in beta. So we're hoping to get that G8. And if you haven't tested that out, that's another great thing to test out. If you want to get involved and help with some of the development on any of those projects, feel free to reach out to me. Would be happy to chat with you there. And I also do a podcast that is #1 in Tunisia. So I am awesome. I have a big following there. Trying to move into some of the other markets. So would love to, have you subscribe to that. So go ahead and, if you're watching on YouTube or Twitch, like us, subscribe. Really appreciate it. And drop us a line and tell us what you want to hear about, either on a podcast, meetup. You want to see a webinar? Tell us. We're open. We're here for you guys. But Charly, I wanted to thank you, and thank you for everyone who tuned in today. I think this was great. Would love to hear more from everybody in the community as we go forward.
Yeah, thanks again for the invitation. It was amazing. So it was a great talk. Good questions here. Yeah, it's always great to be here. I hope we'll meet here again soon.
All right. Well, let's get everybody out in the community space. To say, like, Charly should be doing this full time. This should be his job. He's just on live stream 24 hours a day, 7 days a week. He'll get on live stream. I'll send him one of those old pagers, and he can just get page.
Whenever you're gonna get bored, because I also really like to talk.
Oh no, So all right. Thank you everyone for coming. I appreciate it, and we'll see you next week.
Thank you all. Thank Matt again.